Tungela Resources Limited requires the extension of the South African coal estates, known as the SACE complex, currently consisting as the Greenside and Kwazila collieries, to contribute to the export coal profile. This proposed project is called the SACE Clydesdale Pit project and will involve the mining of the coal resources located underneath the Clydesdale Pan area, applying open-cast mining methods. The proposed SACE Clydesdale Pit project, located within the Mpumalanga province on the western outskirts of eMalahleni, and falls within the Kwazila colliery and Greenside colliery mining rights area. The entire proposed open-cast pit and the bulk of the proposed surface infrastructure falls within the topographical catchment of the Clydesdale Pan. Clydesdale Pan is an endorheic depression pan wetland with extensive associated seep wetlands. The pan is exceptionally large, being the largest pan wetland within the Olifants River catchment. The pan floor is more than 200 hectares in size, but with a much larger local catchment containing different natural habitats represented by terrestrial and moist high-veld grasslands, including a local rocky escarpment. From a hydrological perspective, there are 4 different pathways for water to enter the pan. These are through rainfall directly into the basin, which is the main water input, surface runoff from the pan catchment, interflow from the soils within the pan catchment, and groundwater. The pan is generally shallow and is considered seasonal in nature as it dries up during most winters. The duration of inundation can be highly variable. Inter- and intra-season variability of water levels within the pan leads to a temporarily high variable wetland system that extends to water quality and also biotic diversity. The Clydesdale Pan in its current state has been undermined by the old Greenside underground workings, some dating back as far as the 1930s. Some existing mining infrastructure and facilities within the SACE complex can be utilized for the proposed project. These include the current navigation processing plant, the rapid loading terminal, and the eMalahleni water reclamation plant. The project will develop the Clydesdale open-cast pit together with the infrastructure to both support the mining operation and to manage and minimize environmental impact. The total development footprint of the proposed project is 958.2 hectares. The open-cast pit covers an area of 494 hectares. The key infrastructure in the project area includes topsoil, hard and soft overburden stockpiles, run-of-mine tip area, infrastructure complex to support the operations that include office and parking areas, access roads, overland conveyors, a dewatering pipeline system to the eMalahleni water reclamation plant, and pollution control measures including PCD and trenches. A pollution control dam will be constructed to manage water from the stormwater drains to be fed from the infrastructure area as well as the pit. The proposed mining methods is a conventional open-cast strip mining operation with a combination of dragline, large trucks and shovels moving waste volumes. Trucks and front-end loaders or excavator combinations will be used to load and haul the coal. Coal mined from the Clydesdale pit will mainly consist of the number 5, 4, 2 and 1 seams. Topsoil will be stripped and stockpiled as per topsoil stripping plan. Mining will commence with the creation of a box cut and 2 associated ramps. Waste material from the box cut, overburden, hard and soft, will be placed in allocated stockpiles located southwest of the pit. Coal from the box cut will be beneficiated at the first coal mobile plant and transported by road truck to navigation plant for processing. Coal mined from the Clydesdale pit will be transported by off-road haul trucks to the tip, which then discharges into the overland conveyor system to the existing navigation plant for processing. Mining will continue until the final void remains. At this point, final rehabilitation will be initiated. The final void will be backfilled and reshaped using the remaining overburden stockpiles. Once the backfill, leveling and shaping activities are completed, the proposed project area will be rehabilitated, in line with the defined post-mining land uses, namely, rehabilitate the northwest fringe of the pit area to an arable land capability, the recharge zone, rehabilitate the area southwest and east of the pit to seasonal wetland and areas fit for grazing, the interflow zone, reconstruct the upper organic clay horizon of the pan floor to create a permanent wetland, the responsive zone. The main aim of the pan rehabilitation strategy is to create a self-sustaining wetland system in the post-mining landscape. During the operational phase, topsoil will be stripped from the open cast pit area and stockpiled in line with the topsoil stripping plan and guidelines on handling topsoil. Rollover mining will continue, resulting in topsoil stripped and directly replaced on prepared soil surfaces. Therefore, backfill and spoil material to precise elevation to the correct depth and side slopes based on the final rehabilitation plan will be crucial. Soils in the pan area will be replaced in the following sequence. Number 1. High potential yellow-brown arable soil from stockpile 1 will be replaced to a 1 meter thickness on the recharge zone, indicated in green. This area will not be underlain by a liner and covers an area of approximately 111.32 hectares. Number 2. Grey underlining clay horizon 400 to 1500 mm of the pan floor soil type from stockpile 4, indicated in black, will be replaced at 300 mm thickness beneath the topsoil of the interflow zones, indicated in beige, and 700 mm beneath the responsive zone, indicated in blue. This covers an area of approximately 383 hectares. Number 3. Grey, sandy, temporary and seasonal wetland soils from stockpile 2 used in the reconstruction of lateral flow paths of the interflow zone, indicated in beige. The soils will be replaced at 600 mm thickness. This covers an area of approximately 167 hectares. Number 4. Black upper clay horizon 0 to 400 mm of pan floor soils from stockpile 3 will be replaced to a thickness of 400 mm on the interflow zone in order to restore the pan floor. This covers an area of approximately 216 hectares. Arable sections directly replaced will be revegetated as soon as possible with a grass seed mixture to establish stability in the replaced soils. Seeding will take place in spring and early summer to ensure good germination and growth and prevent soil loss during the rainy seasons. Sections of the pan floor directly replaced will not be revegetated with grass seed mixture in order to preserve the wetland vegetation status. Geohydrology. Post-closure decant of groundwater within the pan area is predicted, regardless if the pan is open cast mined or not. A 10-year active water treatment regime will be implemented to manage groundwater levels below decant levels. In the interim, investigations will be launched into passive treatment options at the Emelaghleni Water Reclamation Plant. A passive treatment plant will be constructed at Emelaghleni Water Reclamation Plant in the next 5 years. The result of this investigation will guide further updates to the treatment regime. Groundwater level management will have to continue indefinitely to prevent damage to the clay liner. The existing seepage plume emanating from the below-ground dump will be hydraulically contained to prevent impact on the pan as part of a separate management strategy implemented by Clydesdale collieries. The permeability of the replaced pan floor clay material and liner is key and will have the most significant bearing on the ability or not to create the desired wetland habitat in the post-mining landscape. The likely post-mining water quality will be determined. Currently, the pan is saline. The likelihood of mobilization of metals and contaminants from changes in water chemistry and distributed pan sediments, as well as from saturated soils, is not anticipated to occur. A large, shallow artificial impoundment or pan is probably more beneficial for water bird diversity, while also promoting water bird numbers. These large dams also provide security and safety for birds when breeding or molting. A large single pan will provide shallow habitat with emphasis on 20 centimeters inundation areas. which may attract more wader species or shoreline species in comparison smaller, deeper systems. In terms of water quality and invertebrate food availability, the inflow of water to the pan should allow for the proliferation of benthic invertebrates and diatom diversification, with the proliferation of navicular taxa, which is preferred by flamingos.